So we'll go ahead and get started. So thanks everyone for coming. This is going to be our offensive IronPython course that we taught at DEF CON last year. It's going to be about 2 hours long, maybe a little longer than that, depending on how many side topics we start talking about and that kind of stuff. But we'll go ahead and get started. I'm Jake, also go by Hubble. I am like a red team lead at BC Security, and then Anthony, you want to introduce yourself? Coin, whatever you want to go by.
Yeah, Anthony, go by coin. I do a lot of the research, so a lot of the crazy IronPython stuff you're going to see is some of the stuff that me and Jake have been working on for what, like 2, 3 years now.
Yeah, something like that.
So it's some pretty cool stuff that we're excited to share.
And next slide. Oh, I jumped the gun. Here's our quick bio, if you care. I started off, I was Air Force. Um, I ran all the cybersecurity testing for fighter aircraft for a few years, and then I got out, and now I run BC Security. And then Anthony, if you guys have been going to DEF CON for a while, Anthony's given a main stage talk on Bluetooth stuff before. And then we've given talks at a few of the villages as well. Anything else you want to cover, Anthony?
Yep, that's good.
So, we're gonna go over kind of this is like gonna be a super intro class to IronPython. So we're gonna go over the basics from like installation, and then basic syntax, and then like creating and calling functions, and then we'll start getting into all the interoperations between the common language runtime, the CLR for .NET, and the DLR, the dynamic language runtime, which is what IronPython runs in, and it was what actually gives us all of the offensive benefits. Is the fact that IronPython is running in the DLR where there's very little instrumentation, so little instrumentation to the point that like the just-in-time compiling for DLR can't be viewed by like WinDebug. Like there's just no ability to like look at DLR right now. It's pretty interesting. Um, so we're gonna start off with kind of introducing the basics of IronPython. You'll integrate it IronPython with C# and PowerShell, and then kind of how like IronPython techniques like bring your own interpreter, some AMSI bypasses, and like Pinvoke work. So the first exercise is kind of more of a pause just for you guys to get your stuff set up. So in the email that went out 10 minutes before the class, there was some directions on um, where to install IronPython from. But if you don't know where to install it, we're going to install it from IronPython or Iron.net, this Iron languages. You want, if in your Windows box you want to use MSI. I'm using a Windows Dev box. You can download them from Microsoft for free, just because it provides like a clean environment for testing where I know that none of the results are being influenced by some like random stuff that I did on a previous box. So when I'm doing like research and development stuff, I always work from a clean like dev box. Um, but I will drop the link in chat real quick. Oh, Anthony already beat me to that.
Yeah, I'll take care of the links for you.
Yeah, cool. And then I already had this open, but we're going to close this, and so I can show you how to set up Visual Studio real quick. And if this is going a little fast, Anthony, do you want to drop the link to the GitHub project?
Yeah, I can do that again. I just did it like a few minutes ago.
Oh, I meant our GitHub for the IronPython or the
Uh,
class repository.
yeah, I did that like 2 minutes ago too, but I'll do it
Oh,
again.
you did. My bad. I apologize. So if you're on Mac, most of this will still work. The AMSI bypass stuff won't work, just because there isn't AMSI to bypass. But the actual IronPython stuff should work. The C# integration, unless you've installed .NET on the box, um, also won't work for the C# stuff. But you can like .NET can run on Mac. You just have to install it. Um, it's just not installed by default. But we'll go ahead and open Visual Studio. And then what I was saying is if you go to the workshop GitHub, There's instructions on how to do all this too. This is just like a quick start for the actual like setup of everything.
And it should supposedly work on Mac. So at least that's what their documents say.
Yeah. So you're gonna want to create a new project when you open up Visual Studio. It may take a minute. If you're running from a Windows box, generally when you're doing offensive development stuff, you actually want to use this .NET framework console app just because that gives you a few more API interfaces that the project will know how to use directly. All of this should work from a .NET like from a regular .NET console app, but I always, unless you're on a Mac or if you're on a Windows box, I'd recommend just using this console app .NET framework. It'll be the ideal way to do it. And you want to make sure it's a C# one and not a Visual Basic one. You could theoretically do all this from Visual Basic as well. We just know the instructions will make sense because it's in C# code. Oh, yeah, I can
Yeah, I was
see.
about to
Uh, I don't know that I can zoom in on this part of Visual Studio.
probably doesn't help you have a ultra wide.
Oh, yeah, here, I can fix that. Will help. Yeah, let's do that real quick. I forgot to do this at the start. Okay, hopefully that should make things more readable for everyone. But when we get to actual code, I can zoom in. This I just don't have a good way of zooming in on this screen. And then you can name your thing whatever you want. I'm just gonna name it like IronPython. IronPython test. And then you're gonna go over to the Project Explorer and go to manage your NuGet packages down here. Has this little symbol next to it. Let's see. Trying to zoom. No, here, let's see. But we're just gonna type in IronPython here. And let it search. Oh, except you want to make sure you're under the Browse tab, not the Installed tab. So we're just gonna install these first two right here, the IronPython and the IronPython Studio. Okay. and then we'll come back to this. We don't need Visual Studio for the first few projects. But Visual Studio is just a sorry, IronPython is just an MSI. I already have it installed on my box, so I'm not going to run this MSI again. But once it's installed, if you go to if you go to your PC and go to Windows C and then Program Files, you'll have IronPython installed.
I think that's big enough.
I just finished installing. Okay. Yeah, you have IronPython installed, and then you can open a terminal here. And type ipy.exe, and you'll open into an iron. Oh, you got to do a slash. And now we're in an IronPython terminal. So like it has your .NET framework type of information and all that kind of stuff. So that's our setup. Now we're going to actually go talk about a few different things in here. In which settings? Go to change the settings from 100%. Just gonna keep going. Okay. So IronPython is an open source implementation of the Python programming language. There's a lot of crossover between the two. They're not completely identical, but the intention is that basically anything written in Python matches IronPython. But it runs specifically in the DLR, which allows for us to do kind of the runtime binding that Python does, where you don't have to predefine variables. You can just kind of throw a value into the variable, and the compiler figures it out for you. So that's really useful because writing like C# code or like statically typed code is a lot less flexible in terms of our offensive development capabilities, in terms of like reflection and grabbing stuff and all that kind of things. We have to have like a lot more structured code that doesn't is not as easy to write and as quick to write. But some of the main reasons that like IronPython is really useful, both from just like a regular standard development frame as well as like an offensive frame, is that there's a ton of integration between IronPython and the .NET libraries and services. We'll show some examples later on. Like you can use like the .NET libraries directly from Python or IronPython. You don't have to have some kind of other interface, like you going through like a COM object or something like that, which you can do in regular Python. But the big advantage is IronPython doesn't have to be installed. We'll talk about that reflection later with the bring your own interpreter concept, whereas Python, you either have to like download the entire like standard library and all that stuff to the victim's computer, or use WebDAV or something like that. So IronPython provides a little more flexibility. And then there's the whole interoperability between all the .NET languages. We'll talk about why that is. And then dynamic typing, as I mentioned. Dynamic typing just makes scripting a lot easier. That's basically the main difference between scripting and programming, is that you can kind of write on the go, and all of your variables are dynamic in the sense that the types are not strongly enforced. So this kind of blends the advantages of PowerShell and C Sharp. The PowerShell is a really useful scripting language used by lots of sysadmins, but it has tons of security features in it now, versus IronPython allows for that flexibility of scripting, but the DOR has like no security features in it at the moment, so you can kind of do whatever you want and doesn't get caught. So it's really nice. And we've started seeing in some of our open source reporting, we started seeing some new Python tradecraft, as well as there's been hints of IronPython being used. The only real major open source reporting on Python is a tool from Turla called Iron Net Injector from about 3 years ago. I don't know if you want to expand a little bit on that, Anthony. This is an opportunity for you to talk about your white paper
Oh,
that got asked about.
I was just gonna send out the white paper and let them go read the journal themselves. Uh, but yeah, so me and Jake did a paper, a journal on IronNet Injector, which, like you said, was Turla's um injector that they built in IronPython. The fascinating part about kind of what they did was they did it from like C sharp into IronPython and then into C. So it gets you into like that unmanaged space. The paper we focused more on just staying all in the .NET environment and what you can do there, which is where we built that the bypass that we're going to show you guys later today. So pretty cool. It's an easy read of like 25 pages, so enjoy.
Academic paper.
Yeah, written as an academic paper.
Yeah. So some of the advantages of IronPython and disadvantages are all that interoperability part. The disadvantages are there is some limitations in the library. There's some weird quirks about like when we do try to run this reflectively, certain things break. We're working on trying to figure out how we can fix those for offensive capability. There's not a ton of community support. It is actively developed. Like you can go if you go look at that GitHub that we linked, you'll see that there was like a commit like 3 weeks ago. But the updates are slow. They're still on Python version 3.4. And the last like formal release update was back in August of last year. So they do like updates like once or twice a year as like formal updates and not just like code getting pushed to the repo while they work on it. Um, and then there's just whenever you're doing offensive security research, you're already kind of operating in the fringe because you're trying to make stuff do what it's not supposed to. But IronPython is even more so in terms of the lack of like talking to people that know how to do it, because there's just not a lot of open source reporting on using IronPython right now. As well as the language is not super widely adopted. It's used in a couple of things. There's actually some game development engines that use IronPython. And that's kind of the primary community right now. And so it's very much just focused on using those specific gaming engines and how they provide interoperability for those kinds of things is what you'll find online. There's not a ton of like just straight IronPython, like how do the libraries work and all that kind of stuff. But the community on the GitHub is pretty responsive to questions. And then you can try and find someone that knows stuff. Anthony and I were happy to answer questions if anyone has them after class. So now we kind of got to talk a little bit about like what is .NET. This is my favorite definition of it from Bytebleeder. It's a language independent development platform comprised of a set of tools, infrastructure, and libraries that enable you to create cross-platform applications. So if you're familiar with how like Java works, how it has the Java runtime, and then that allows for you to have it portable across any operating system because you're running in that Java runtime, and as long as your code is conformant to those standards, then you let the runtime handle all of the interoperability between the actual OS. That is kind of the same exact thing that .NET is going for. It's just Microsoft's version. Actually, remember, Anthony, you probably remember, didn't .NET start as a split from Java, or was it a different runtime environment that it initially, like way
Uh,
back in like the early 90s
if
caused?
I yeah, if I remember correctly, I think Microsoft approached them and they wanted to cooperate and kind of do their own thing, and then essentially they broke off because Java wanted to keep all their stuff close held. Um,
Yeah,
it's been a while. I don't remember the full story, but
yeah,
they the
something
whole
like that.
idea behind it was they wanted it to be like they wanted to use Java originally, and they ended up building .NET Framework
Yeah.
instead.
But you'll keep hearing us say .NET Core versus .NET Framework, and it's in another slide in a second. But the first overview is this .NET Framework piece, which is the interface for Windows specific. So it does get rid of that dependency on knowing like the architecture of the OS. You can run it as like your code will run on a 32 or a 64-bit, like it can run on either one. But the .NET Framework is a Windows-specific implementation because it allows for access to the Win32 API calls, which are not like direct kernel calls, but they are like OS APIs. So those Win32 APIs don't exist on any other platform. So if you're using them directly, like you can in .NET Framework, your code isn't portable to Linux or Mac because those Win32 APIs just don't exist. Where you'll really see this in IronPython is C types. That's actually like a Python library that has also been converted over for IronPython that allows interaction to those like lower level operating system calls. That is what allows you to do like memory dump and like byte manipulation and that kind of stuff in memory. You can do like shellcode injection, which we'll show like at the end of this, and all that kind of stuff. But the .NET framework's huge. It includes everything across like VB, C#, JScript, JavaScript, all those kinds of things. VBA, if you still want to go write some Windows macros, is technically part of the .NET framework. So this just shows kind of more interaction between everything. Everything starts off as source code in your various language. Then it gets passed into what's called the common language runtime, which is the just-in-time compiler, like that Java runtime environment, the JRE, that does all of your compilation. That's what the CLR is. It's called the common language runtime. You'll see some interchangeable terms of like Microsoft intermediary language or common intermediary language. That's because Microsoft tried to make this an open source project and make it an industry standard as a result. It is open source, but they try to make it an industry standard as a result of it being open source. So they tried to eliminate like all the terms of like Microsoft intermediary language and that kind of stuff and make like common intermediary language. That hasn't really took up anywhere, but it is technically a published standard on what that intermediary language is. But then it goes through the just-in-time compiler and gets turned into actual machine code. There are this is what we call our managed code, which means that there's that runtime environment that does like memory management and garbage collection and cleanup and all that kind of stuff. And then there's unmanaged code, which is your traditional C, C++ code that gets converted directly into computer language like runnable code, and you are responsible for doing all your memory management there. So the core piece of .NET is what's called an assembly. Everything in .NET is an assembly, basically. A DLL and EXE are technically different things, but in .NET they're all assemblies, and they can kind of be used interchangeably. Really, the only difference is that an EXE has like a main function that automatically gets executed, and a DLL doesn't have that function necessarily. But when you're loading things into memory reflectively, like .NET really doesn't care if it's a DLL or it's an EXE. They treat it the same. It's just an assembly. But because of that managed versus unmanaged code part, a .NET EXE or DLL is different than an EXE or DLL you get from a C program. They can't be ran directly by the computer. They have to be ran within that common language runtime. So it'll still say .exe, but like you can't convert that .exe into a shellcode and directly inject it into memory, because there's not that common language runtime that knows how to run that shellcode, because it's not really truly shellcode. That's what Donut does. Donut wraps the CLR for you into your shellcode so that the unmanaged process that you inject into knows how to run the code. It loads all those pieces for you. But you have to use something like that if you want to inject a .NET assembly into like another process's memory. But there's But otherwise you have to have like shellcode and write it in like C++. So I already hit on this. The common language runtime is responsible for your just-in-time compilation of your common intermediary language code. And then everything that is a .NET language gets compiled into that CIL. So regardless of its C# or its VBA or JavaScript, those all get compiled into this intermediary language and then executed. Even PowerShell does go through this intermediary language. PowerShell is kind of a pseudo COR language. It operates a little more in the DLR because of some of the ways it does context handling for the scripting. So you can't, like, a lot of these codes you could compile into IL code and then just go execute it in the COR and like transport it across any computer. That's what, like, when you compile like your C#, it's doing. Theoretically, like JavaScript and some of that other stuff you could, or VB, you can do the same thing. But PowerShell you can't really, because there's some weird context stuff with the compiler that gets added, so it can really only be ran through that compiler at runtime. So DLR is kind of what we're really here to discuss with IronPython. It's a runtime environment that adds a set of services to the CLR to make it easier to develop or port dynamic languages. So it runs through a different compiler. That's the main thing. It does pseudo go through the common language runtime, but it doesn't go through that same just-in-time compiler. It has a different base class language compiler because everything in the DLR gets converted into an abstract syntax tree. And that syntax tree gets compiled via like a link expression compiler, which is a different compiler than the just-in-time compiler that the CLR usually uses when you pass it in an assembly. So we just got asked, can you pass a good resource?
I sent
Yeah.
him the book of the runtime.
So when you get deep into this stuff, the book of the runtime is like very verbose. There aren't a lot of blogs on on all these differences that kind of like give you like the too long didn't read. Especially when you start talking about the DLR. Like when you start getting into DLR land, it's like this kind of magic. You have to go find some people that know it, and they're the only ones that really talk about it, kind of thing. Seemingly Science runs a PowerShell Discord. There's a few guys on there that know a ton about this, but are they're kind of unique. And like when I've asked for blogs and other stuff to like give to people, no one's really known anything. The Book of Runtime's kind of the best answer for that. Or just ask questions to Anthony and I, and we can do our best to explain it.
I'll post a Discord in case anybody has questions ever.
Yeah.
Tends to be a good place to get a hold of us.
Mm-hmm. So it's, like I said, Seemingly Science is really just a set of APIs for interacting with the CLR. He says it because of that part I said where the when you build an IronPython language, IronPython like language, whether that's Iron Rust or like F# or S#, those kinds of languages, that's because everything uses an API that converts everything into abstract syntax trees, and then those trees get compiled. And you're just using an API to convert your text into those trees through known associations, and that's how you write a language and develop it. Because technically, anyone can develop a new dynamic language runtime language. So if you were super dedicated, you could go create your entire own language, and yet like basically no one would ever be able to detect it because you'd have your own abstract syntax trees that get compiled that break like your code signatures and all that stuff. It would be very, very difficult, although very labor intensive to build it. But it would be cool. If you want like a graduate level project, you can go write your own language and show how it breaks like all detections for security. So The DLR enables scripting languages. As I mentioned, the DLR is like sort of a, sorry, PowerShell is sort of a DLR language, but it has some weird legacy and state issues. The cool part about all of this is that the scripting engines for these languages are .NET assemblies in and of themselves, which means they're interoperable from any of the other .NET languages. So we can load these assemblies from PowerShell or from C# or VB or whatever, um, because they are .NET assemblies in themselves, and all .NET languages can interact with any .NET assembly. So this is what really enables that bring your own interpreter concept that we'll talk about in a little bit. But when you define a DLR, a dynamic language, you create a language agnostic abstract syntax tree known as a .NET expression tree that can then be compiled into MSIL and executed by the CLR, which is pretty cool. But in order to do all of this stuff, we have to be able to leverage reflection. And reflection is what makes the .NET framework so powerful for offensive purposes. This is like where the concepts like BOFs, if you're in C, to allow for like updating your code as you go. BOFs are basically like a pseudo way of doing reflection because C and C++ and those kinds of unmanaged languages don't really support reflection. But reflection allows you to modify your own code in memory. So like you can have an assembly that modifies itself. It can look at itself, say like, hey, I don't like how that function is written, and rewrite the function in memory, is what reflection is letting you do. And so because you can change that, that allows us to do all kinds of things where we send code over that looks like benign, but then we send an update that causes a reflection that causes it to modify itself, that introduces new capabilities that allows you to start doing all the stuff that you want to do, as well as like how you send tasks across to like a .NET like agent or beacon like implant. Reflection is how you're able to like execute those modules as you send them across, whether that's like through Covenant or Empire or whatever you want to use. So we've hit on this interoperability part a bunch. That's because it's the most important aspect of why this works for using IronPython. We mentioned that embeddability part of because it's the interpreter is a .NET assembly in and of itself. We can embed it into other .NET programs that allows us to start with a C# or a PowerShell stager and then launch our IronPython once we've landed on the box, because none of these machines have IronPython installed on them. So we have to start with a language that is installed on the computer, and then migrate over to our IronPython as we get there. And then the reason that it's attractive from a offensive security malware development standpoint is that interoperability gives us all the advantages of traditional .NET, but and allows us to do like a lot of the quote unquote living off the land stuff because we can run from languages that are already installed on the computer. But it provides us an interactive tool that is not really monitored by any security solutions. And that would require, and we'll talk about this more at the end, but this isn't just a simple matter of like it evades EDR because they're not looking for it right now. Like they're just straight up aren't like ETW events that are produced for dynamic language stuff being compiled. Like you'll see the initial loading of like the IronPython assembly, but unless you're gonna start flagging on entire programming languages in and of themselves being loaded on a machine, after that, there are no additional ways to collect data on what is being ran by the system. And that's just like the way the DOR is written right now. So it would require like a significant overhaul by Microsoft to change the fact that like EDR can't see these things right now.
Yeah,
they can still yeah. Oh, go ahead.
Oh, I was going to say there's fundamental flaws in the way that .NET is operating. So no matter how many signatures they generate off these things, they still can't detect off of them because there's no way to actually collect the events.
Yeah. So there are still behavior things that you could flag on. So like trying to dump LSAS is like still going to get flagged because you still have to open a handle to the LSAS process. So like there are still like behavioral detection things that like will get you caught. Just like process injection is still super noisy because the way you're opening process handles and all that kind of stuff. So there are ways to get caught, but like the actual malware itself can't really be collected on because there just aren't hooks in place for it to be collected. So just to go over some IronPython syntax real quick. If you have programmed in Python, then you kind of know the syntax for IronPython. It's essentially the same.
Congratulations, you already know it.
Yeah. But in case you haven't, the biggest thing in Python/IronPython for development is that indentations matter. Is the main way that it defines blocks of code. So you have to make sure that all of your indentations match. Like if you use like an indent, like you can use indent or spaces, but you can't use indent and spaces for like one block of code. It'll break things. Like it's like that kind of stuff. So just thing to keep in mind, comments are started with hashes. Um, Variables. This is kind of the whole definition of what makes a scripting language / like dynamic language is you have this x equals 5 and y equals hello world. We could make two more lines here that now says y equals 5 and x equals hello world, and the compiler is totally happy with that. You don't have to define that x is an integer before you pass in 5, or that y is a string, and those two variables don't always have to be those types. They can change on the fly whenever you want them to. And that's really that is the core definition of what makes like a scripting language versus like a traditional statically typed language. And is the whole purpose behind why this whole AST tree thing and DLR languages even exist. So there are 3 types in IronPython/Python. This is actually one of the major limitations of Python and IronPython as malware. Is the fact that you only have these 3 types, as well as the fact that you can't necessarily force a specific type in Python/IronPython, unless, which we can, if people are interested in getting this in the weeds at the end and we have time, you can talk about it. You can use the .NET variable types to cast your variable into a like a uint or a uint16, like those kinds of things, which becomes important when you want to use the Win32 APIs. Like I said, we could talk about that. That's getting like very in the weeds of the programming. But it is a limitation that you have to be aware of, that you have to use .NET types if you're doing anything that involves memory manipulation or the Win32 APIs. You can't use the native Python types. The other weird thing about Python is bytes are not consistent across Python versions. So like we have been trying for a while to in Empire make it so that you have like a Python 2.7 agent and a Python like 3x agent. But they did something that changed how like bytes are managed in memory. And now like if you kind of try to do like any type of encoding / like encryption, like it just breaks everything because the data doesn't come out the same way when you encrypt and decrypt it. Am I saying that right, Anthony?
Nope, that's right.
Yeah, yeah. Um, um, so, and then you only have one text type, which is string. You do have bytes though. You can create a byte array in Python. And then you have a list, tuple, and range. The big thing, if you haven't used, if you're just starting on like actual programming yourself, tuples can't be changed. Like once you create a tuple, it's static. You can't add and take items out of a tuple, but you can take items in and out of a list. So that's the major difference between those. And then you have a dictionary type.
Now everybody's a Python expert.
Yeah. So someone just asked, should I make a new IronPython test project based on a Windows console app? Yes, that's how you want to set it up. We'll go over that again when we get to the exercises that do it. But yeah, you want to use a Windows console is what you want to be building. And then you have booleans. So now we're gonna get into creating and calling functions. So we'll do this in the next exercise where we'll play around with stuff a little bit. But same as Python, exactly the same as Python. Definition, function name, and then any inputs, and then a colon, and then an indentation of some kind. Tab or space. Just gotta make it consistent. And the same number of spaces. That's two. Can't do 3 spaces and 2 spaces. And then Anthony, you want to talk about modules? You understand this a little better than I do.
Yeah, so modules, if you're familiar with how like Python works, are essentially just like your imports. They're all your packages that you can bring things in with. So if I want to use like something simple as like OS allows me to like run commands at like the OS level. That is just like a Python package that's pre-built into Python in general. It's what kind of like makes Python so awesome is that there's packages for like everything. Uh, like you name it, there exists a package for it, right? Um, Now it gets really interesting because with IronPython, you not only have the standard library of packages, you also have like these other packages, and I think that's what the next slide is, right, Jake? Nope,
No, just
nope,
showing using it.
just how to use these.
Yeah, these are what you're talking
This
about.
is what I was talking about. So IronPython has a special type of package called the CLR module. So the CLR module allows you to get access to those low-level CLR functions that are in C# and PowerShell and everything else. So essentially what you can do is you can load those DLLs completely from IronPython, which allows us to do some really crazy things that we're going to show you in a little bit, like loading, the system.automation DLL and then making modifications to it. Uh, that's what allows us to do those bypasses, for example. So there's a lot of capability just by using this without us even having to go back to C#. Now, under the hood, IronPython and every other DLR language is just C#. So kind of inception now.
Sort of, yeah. Except the dynamic code that those interpreters compile are not C sharp. So it gets very fuzzy and upside down ish. Like if you go read the white paper, Anthony has like an example of basically the like 4 level down inception type of thing between like running a PowerShell on an IronPython in a C sharp program that
We're
runs
gonna be
like in
running C
unmanaged mode.
sharp. That's running Python, which is running C sharp, which is then touching something else.
Yeah.
It's okay. It all makes sense.
Yeah. So now that we're into the next phase, we're gonna just go play around with some of our IronPython stuff just to get a feel for it.
Do you want to show everybody how to open this up real quick again, in case they
Yep.
missed it?
Yeah, so when you install, if you get lucky, it'll build you I forget to. If you get lucky, it'll build a path and you can just type like ipy.exe and it'll like auto execute. But in my experience, most of the time it does not. So what you need to do is navigate to the folder that IronPython was installed in, which like 9 times out of 10, unless you specifically changed it, is this program files IronPython 3.4.
You could also type IPY or IronPython console in the search bar sometimes. If you set it up
Yeah,
to globally
yeah,
like do everything, then it should be there as well.
yeah. So you can also come down here and type IPY. I very rarely do it this way. But if you do that, then it just opens like a straight up console that's different than the PowerShell one. Um, in the sense that it just drops you straight into this console instead of having to open the PowerShell and then run the console again. But so when you're running from a IronPython, and this is true of Python consoles too, like you can evaluate individual expressions. So like we can say,
Can you use the bigger one,
oh
Jake?
yeah,
Thanks. Or
yeah,
just make that full screen then.
yeah. So like we can evaluate like individual lines here, and it'll still run. But we can also do define like a function from the console itself. So if you do this like definition, hello world, everything that's going to build up when you hit enter, you'll see these 3 lines, which means that it's still interpreting what you're putting in as one command. So now you don't need a tab or anything when you get this if you're executing from the console directly like this. We can then like type a print statement. Oh. I can't type. There we go. Expected. I shouldn't
It's
need
because
to.
it's because you have to indent it. Yeah.
I didn't think you did. Oh, I lied. Don't listen to me. You do have to indent it still. I thought the thing, whatever. Yeah, so once you want to exit out of it, you'll have to hit it twice. You always have to leave a blank line at the end. But now, if we type hello world, it'll execute for us. And now we have a definition that's been defined. So this is really nice when you're trying to like troubleshoot something. But it is really unwieldy to enter like large scripts in this way. So there are a couple of different ways that you can do stuff that I'm going to show you, like on how to execute Python scripts, so you can like write your longer script and execute them and get feedback that's a little easier. So if you go over to the exercise right here, you'll see this this pre-built like little tiny script here for us that's just going to kind of show a few different things here. So I just put that into a script on my desktop, which is like this hello world.py here. So there's so if we want to execute directly from our like within our interactive shell, we kind of have to do it slightly janky. We might have to import system first. We'll see. But we'll try this first. And I'll drop this command into chat. Oh, someone asked if you can clear the screen. Yeah, you can just type clear. You just type clear it'll.
You're not in yeah, so you're not in a because it's the IronPython console, I don't think you can.
I thought you could. Okay, never mind. So maybe not from the Python console. So we'll go just. So well, you can do this exec open. Like I said, we might need to import system, but we'll see if it yells at us first. So like if you grab the path to wherever your script is.
I posted a way to clear it in a more Python-y way. Yeah, Jake, if you want to do it that way, you have to do what? Oh, okay.
What?
Oh, though I wasn't sure which way you're trying to run the file. Sorry, never mind. Disregard.
Yeah. I don't know why it didn't like this. That should have worked.
I would do it the other way.
Yeah, we'll just do it the other way. I'll play with that later. So the easier way is to just run your IronPython this way, and you can pass it this script this way. Oh, it might not like that. It's a dot text. I know it runs this way, but the other one might not like that. So you just run /ipy.exe path to the file. And then we'll do it on later events, but then you would pass in your arguments for whatever your Python file expects. You can pass in stuff to your script that way. So we'll do that later, but we'll give you guys a few minutes to play around with that. If anyone has any questions, I'm gonna try and figure out why.
Did you talk about the difference between the two functions?
Which two functions?
Here.
Oh, no,
Yeah.
no, these functions. Sorry. Yeah, sorry.
What is import system like and all that?
Yeah. So import system is pulling in your your system module. That's actually a Python module, not a CLR module. So system has a bunch of stuff that is predefined. So if you do this system.environment.version, that's actually like a random Python object. So you have to add this .toString, which basically all I'm sure there's an exception to this, so if someone knows it, feel free to correct me. But pretty much all Python objects are capable of being serialized to a string with this .toString function. So you take a Python object, do a .toString, and it'll print it out. And then this is just a regular print function that says print hello world from IronPython, and then this is our function that we define that grabs our .NET version from our variable.
So the fascinating thing here is, like Jake said, import system is a Python package, but really it's pointing to like that like system DLL, which allows us to access the CLR and then run. In this case, we're running some .NET functionality inside of Python right now.
Yeah,
and that's where we're extracting out that version number from.
Yeah, so like if you used this, correct me if I'm wrong, if you use this in a regular Python window, it would give you a Python version, not a .NET version.
I don't even know if it would work because I don't think import system works in regular Python.
I thought it did. Oh no, it's import OS. That's right. I'm just getting things confused. Yeah.
I'm having installing the CLR package via PowerShell. I don't know what that means.
Yeah, you shouldn't need to install a CLR package via PowerShell. The CLR is already installed on Windows. Yeah, in Mac OS it's import sys and import OS. Yeah.
Yes. But import sys and import system are not equivalents in Python versus IronPython
Yeah.
because we have that CLR now.
Yeah.
That's the big major difference between IronPython and regular Python.
Yeah. Yeah, I apologize. I misspoke. I forgot to import OS normally in Python, not system.
So the IPY file is essentially just our compiler. It's like our console/our compiler in this case. So that's what accesses the IronPython DLLs that then compiles it and then executes the program. That's kind of it.
Yeah, so it doesn't compile in the sense that you can get like an exe out. But
that
it
requires
does
C#.
Yeah, but it does compile it in the sense that it's converting it into machine code to be ran by the computer.
Yes.
Yeah.
All right. You ready to keep going?
Yeah. So we talked about this a little bit, the difference between managed code and unmanaged code. Managed code is anything that's executed by the CLR. CLR handles all of our memory management, garbage collection, all that kind of stuff. This code exists as IL code when it's compiled. So therefore it can't be executed without a CLR to manage the memory for you. And can't be directly injected into process memory. But unmanaged code can. So it is possible to host the CLR in unmanaged code. As I mentioned, that's what Donut does. It's also how Cobalt Strike's execute assembly works. It spawns a sacrificial process, loads the COR through the unmanaged Windows API, and then passes that COR that it has loaded up the assembly that it wants to execute, and then the sacrificial process dies once it's completed. So this is kind of where we first get into a little bit of hints about why this is so much better for offensive use than traditional CLR stuff. The CLR, open source CLR, is like .NET Core. It's technically not the same CLR that is being ran on a Windows box, but that is still like pseudo closed source. They don't publish it on the internet, so the best we can use is the open source .NET Core. But I have yet to find any outside of those Windows APIs that are available in the .NET framework. I've yet to find any meaningful distinction between .NET Core and the .NET framework that is actually ran by the Windows box. So if you go look through the .NET open source project, where you find when you go look at where it loads assemblies, it has this comment in there. Oh, let me change my pointer. So it changes, or it has this comment in here that's really interesting that basically says that the assembly is only passed to AMSI on assembly.load, because it's assumed that if an assembly is being loaded from disk, that some other form of scanning has been done on that assembly, and therefore it's not malicious. This is the only place that currently the CLR has any security hooks in it. So when we load up our IronPython language, or our IronPython code, or sorry, assembly, that gets sent to AMSI, but because it's just a language compiler, there's no way to be able to just say like, oh, IronPython automatically malicious. I mean, you could, but it would be potentially breaking in an organization to just say like, hey, these language assemblies aren't allowed, block all .NET assembly loads that involve them. Not to mention that there's ways to obscure your assemblies that make it harder to detect. But once the IronPython assembly has been loaded, which at the time the assembly is loaded has nothing malicious about it other than it's in a language assembly, nothing goes to the CLR security features after that. When you load assemblies, there's also some, and like the just-in-time compiler does some things for traditional like C# assemblies. There are some ETW events that are triggered, but the DLR doesn't trigger those because it's using a different compiler, and so it doesn't use those same ETW events. But there's also another cool project out there called like Sharp Transacted Load from Golden Gun Sec that allows you to load assemblies from memory that tricks it into thinking that it was loaded from disk, so your assembly never gets loaded or never gets scanned by AMSI because it assumes that it did it somewhere else. Also interesting to note, the on-disk scanner that Defender uses has a different detection library than AMSI does. So they actually have two different detection profiles. And it's usually easier to get past the on-disk scanner than it is to get past the AMSI scanner. So just something interesting to note there. And now this gets to the bring your own interpreter concept. This allows for the execution of other DLR languages on the fly. It does require the DLLs from the language. So this does create quite large implants in memory because you're loading all of the associated DLLs from the language into memory. That being said, on modern Windows, memory size doesn't matter nearly as much as it used to. It used to be that there was a very large philosophy that like you wanted all of your implants to be as small as possible so they didn't look suspicious because memory usage was like very restricted. Now you can, open up Task Manager in Windows and see a dozen programs that are using like tens, if not hundreds of megs of memory. Like, Chrome is probably using a gig of your RAM if you let it. It's not nothing else is going on. Um, like Sliver is really cool. They make like fit their implants for like 50 megs. I know someone was saying that they think that part of the reason that like Sliver may be so hard for EDRs to detect is that the implants are so big that it just has a hard time scanning them effectively because there's so much garbage in them. So there are some advantages to like large implants. Um, but large implants are not in and of themselves bad anymore like they used to be. Um, And then we avoid all of our PowerShell security instrumentation because we're not using system.management.automation DLL anymore, which is where all the PowerShell security features are included.
So yeah, go back to your laser pointer.
There we go. Um, yep. And then as long as the interpreter exists for it, you can run any language. So here are a bunch of languages or a bunch of examples of different languages. Boolean is what Bytebleeder wrote Trinity to use, which is kind of the only like fully bring your own interpreter C2 on the web, but he also hasn't updated that in like 5 years. So technically exists, but not super functional anymore. Do you know anything else about any of these other languages besides they exist? Boolean and IronPython are really the only two that I've done a
Yeah,
lot of.
that's about it.
Yeah. The other ones technically exist. They're projects on GitHub.
I mean, I have the examples from our offensive DLR stuff that we forked.
Oh
So
yeah.
if people want to play around with those once you get into more of that stuff, but um, yeah, you can play around with some of the languages. There's Boolean in there, IronPython, obviously, S sharp, F sharp, like you name it, they're all in there. So
So now we're going to look at invoking IronPython from within C sharp. Um, I'm also think we're going to take like just a quick 5 minute break so I can grab some water and give my voice a break real quick. So if you guys want to start running through that, we're going to take
yeah,
a quick 5 minute break and I'll be right
I
back.
will link it, and that way people can get started on it. And then when you get back, you can walk through it.
Yeah. Yeah, so we got a question about is like has anything changed in the last 5 years that would make Booleang obsolete? I don't think there really is. It's more just like the like silent trinity hasn't been maintained, and when the like server side of the C2 is not maintained, it kind of quickly starts degrading in terms of like stability and stuff, just because of code base changes and that kind of stuff.
Anybody who
So
wants to build their own C2, talk to us and we'll tell you not to do it. More time sunk in that than anything I could have imagined. Thousands of hours.
yeah.
I have no idea what a C2 even is.
So C2 stands for command and control. It's how like Empire, it's what Empire or Cobalt Strike or any of the quote unquote hacking tools that you hear about APTs and red teams using. Um, that's what those frameworks are. Anthony and I and Vincent, who is not here, run the Empire C2 project. That's what Anthony is referring to. So I'm just going to grab this whole script that is in here, and we're just going to walk through what it does real quick.
See how many more windows you can open before the end of this.
Okay. So this top section, you never done anything with C Sharp. This is how you reference external libraries that the code needs to access to be able to use certain functions. So like um, if you had written a previous program or library um, and you want to use functionality from it, you'd use this using statement, and that's how you pull it in. So it's essentially equivalent to the import statement at the top of Python stuff. So you could name this IronPython namespace. I recommend making it the same as your project, just don't so you don't forget it. But technically, the namespace can be whatever you want. But if you're using it in reflection, which we're not really gonna go over too much here in detail, you have to know what that name is for the assembly to be able to reference it. Then this is our class, is our main program class. It's very standard C# naming convention. You have your main function. This is what actually distinguishes in .NET a program exe from a DLL. If you don't have this, you can still be compiled into assembly. It just won't run as an exe. So this is where we actually get into the nuts and bolts of what we're doing. The first thing we do is you have to create a scripting engine. So this is kind of loading up our runtime environment equivalent. So we're creating a Python engine that's defined in the Python DLLs. We're then defining our code, which is like a hash string. This hash string just means that there's a formatted string. So if you don't have this in there, this @ symbol at the beginning, the compiler may collapse like your spaces and in your indentations and stuff. It won't keep it formatted exactly as presented.
Which is a problem in Python.
Which is a major problem in Python. So you just want to make sure that you're using it like this. Then our script source is going to just create a script source from string. So this is passing in our string. If you've ever done like script block.create for PowerShell, same exact thing. It's just taking a string, converting it into code for you based on nomenclature. In this case, it basically just straight up converts it to it's essentially it's still a string. It just defines it as like a hash table that means it's immutable and some other computer science stuff that we don't really care about here. So we pass that script source in. based on the engine that created it as a script, and then we can just execute our script because the engine has attached it to a runtime environment. And then we're running the exact same script that we did in the first exercise, but instead of running it by going into the interactive console directly or using that IPY interface, we're going to compile it into our own exe that doesn't need a IronPython console to execute. Because when you do it through IPY.exe, you're still attaching it to a console. The console window is just kind of like hidden from you, but there's still a console window attached, which has a whole another thing in terms of IronPython. There's a lot of stuff in IronPython that has to be attached to a console window or it doesn't execute properly, which if you want to get Anthony to go on a tirade, buy him some drinks at a conference that you go to and ask him about console windows in IronPython. Because it took him about 2 months to figure out that's why one of his projects was failing, was because there was not a console window attached to the project.
So now I spawn invisible console windows because that's more efficient.
So we're just gonna go up here and build our solution. And I shrunk it down. It'll start building. Yep. And then we can just, so there's like two ways of getting to your code. You can either right click on here and like open folder and file explorer, and it'll take you to your project, and then you just want to go to bin, which stands for binary, then debug, and it'll be in here. Alternatively, when it does compile, it'll give you the file path, and this is.
I see it.
Hopefully, I got the mic away in time. It's not blow out everyone's eardrums. I apologize. Alternatively, you can just grab the path from down here and browse to it. Just cut and paste it. And then if we just double click on this, it'll eventually run. It's a VM, so it runs a little slowly. And then we get the same thing that we got before. The press enter to continue is just to hold open the console so you can read it. If that line wasn't in there, it would just flash and close so you couldn't read it. So it's just there to hold the console window open long enough for you to read it. Which is what's up here. Is basically this console.readline is how you get user input, but we didn't give you, like, technically you could type something in, but it doesn't do anything with it. So it just waits for you to hit enter.
Yep. And then something important to go back, Jake, into that folder. So we brought up bring your own interpreter earlier. So this technically isn't bring your own interpreter because the DLLs are required. So if you notice, we have like the IronPython DLL and all these other DLLs that are here. If you wanted to like make this so it can be transported, you'd have to take all those DLLs and embed them in that executable, and now you can transport it anywhere. Otherwise, you're relying on the fact that IronPython DLL is installed on whatever your target is, which is a big problem because I'm gonna guess before today, 0 people here had IronPython installed besides me, and maybe Jake.
Yeah, so we use the Covenant compiler because it has why am I totally blanking on the name of the project he built before that?
You're talking about the Roslyn compiler?
Yeah, but he has the project that integrates all the DLLs for you.
Oh, got it.
That splices everything together into one DLL, so you don't have like a whole bunch of shenanigans going on. That's why we run through that Covenant compiler. But again, getting into technicalities that no one here cares about.
Me and Jake are giant nerds for this stuff, so yeah. We could go down tangents very easily.
Yeah. So that's just running that. That's the first example. We'll go back to our slides now. Does anyone have any questions so far about that? So now we're gonna get even more into that .NET integration stuff that we've been talking about. So we're gonna import the CLR. So we did that import system, which does get you access in that previous one that we've been using to get that environment variable. that gets you access to some things. It doesn't get you access to everything. This is where we're gonna start going down the rabbit hole of like fringe kind of. You're not gonna really find any documentation or anything on how to do this. You're just gonna have to find like random like GitHub questions that people posted trying to do it themselves and learn from that. But when we import the CLR, that's what gives us initial access to the .NET libraries. If you want to use a specific .NET library, you then have to add the name of that assembly into the CLR. Once you've done the CLR.add reference, you can then do that system import from the library that you referenced. Sorry, spring here. There we go. Okay.
The reason why so me and Jake discovered this when we were trying to do things with pipes in IronPython. Because we thought you could just import them, and it turns out you had to add the reference to the DLL first, and then you can import them, no problem. But a lot of that stuff gets very, very weird because you got to figure out what DLLs are dependent on other DLLs, and then you start running into a bunch of, lack of better words that Jonathan said, shenanigans.
Yeah. So you want to talk about this, Anthony?
It was more for reference than anything else.
Okay, yeah.
Yeah. So
yeah, so you can handle .NET events, which are like certain triggers and stuff associated with ETW stuff. You can inherit from .NET classes, sort of. Inheritance and extension are programming concepts where, like, if you define a car class, you could then define like a Ferrari class that, you know, automatically inherits the fact that a car has four wheels without having to go define the four wheels stuff yourself. So IronPython does support inheritance, but it's not perfect. Certain things break. But so now we're going to go to exercise 4, and we're going to go a little more in depth on this stuff. So we'll give you guys a few minutes to work on it yourself. If anyone has any questions, feel free to ask. Oh, okay. Actually, I'm just going to go ahead and walk through it because we are starting to run a little short on time. So
that way everybody can just follow along with him.
yeah. So we are going to go ahead and just paste the stuff from the end. So I'll walk through the code again.
Doesn't help we're trying to squeeze 4 hours of material into 2 hours. Actually, it's more like 6 hours of material that we squeezed into 4 hours that now we're squeezing into 2 hours.
Yeah, but who has the attention span for a 4-hour class?
We know Hubble doesn't.
That is a true statement. That's why I make the classes. It helps me pay attention more. So we are doing the same thing we did before. You may notice that we have like one additional line here. I think that was. Oh, no, we didn't. Never mind. We did have that scripting one last time. I lied. But so this main it's the system.I. It's when we do the PowerShell one that we get the extra line. Jumping ahead. So this first part is again just our main function that tells it what to do. We're then going to like call IronPython. Let's see, I'm just making sure that I got the right. Yeah, okay. So we're gonna then do our call IronPython stuff again. We're building our scripting engine and our scope. So this part is different than last time. So down at the bottom, we've defined this public class hello world, which is a just a C# class that you use in your code here, but like IronPython doesn't know what it is natively. But because IronPython is fully interoperable with our C# code, once we've defined the class down here, we can construct a new version of that class, which then makes it an object and pass it to Python as a variable. So we're setting the hello world variable as that class that we built after the construction, because we can pass our assemblies are interoperable. And then we can call this variable later on. So we're printing in our, we've defined a greet Python function, which is we're saying hello world to the base name from Python itself. And then we're using our C# assembly here that we passed in. So this is how you reference stuff in C# or variables in general. Is the assembly was passed in because of our class. So we have a hello world, and then our function was say hello, and you pass in a variable, and that's being ran by the underlying C# code that is accessible from IronPython because it was passed in as a variable. So we can, this is just a random name. We can make this say Hubble. And then we call our two functions. We then, again, once our code has been defined like this, we pass our string to our constructor for the engine. And the part here is that we're passing in a scope. So I mentioned, so scope is a way of defining for your compilation engines what a lot of people think of as global variables. It's not quite that simple. There's a lot more that goes into scope that has to do with like the resources available on the computer, the architecture, all that kind of stuff. But you can kind of think of how you pass in, this is how you pass in global variables when using IronPython this way. It's probably functionally close enough to think about that way for most things that you're going to be doing. But the scope is how, like, it's where all the security feature definitions and stuff are defined to. But we pass in the scope to execute against so that it knows what that hello world variable is. So we'll compile this and then we'll go ahead and run it. And so now it says from Python and from C#. So again, you can see this hello world here is not defined anywhere in our Python code. It's only defined in our C# code that we passed in as part of the variable scope. So now it can access that assembly and execute that way.
So now it's C# calling Python, calling C#.
Yeah. So does anyone have any questions about that? Cool. So we've shown how you integrate with C#. Now we're going to show how you integrate with PowerShell, because PowerShell still has a lot of uses. Even on the offensive side, even though there's a lot of security features in PowerShell, most APTs still have a number of things that they run in PowerShell. Like I was just reading one this morning about Fancy Bear using PowerShell for dumping like deep happy keys from targets. Like the rest of the code was written in other stuff, but they still had certain PowerShell modules that they ran just because it's easier to do it that way. And running in certain things in PowerShell aren't going to get you caught all the time, so they still do use it. Run spaces are kind of those engines that we've been creating for, like when we create a IronPython engine, PowerShell has what it calls a run space, which is kind of equivalent type of thing. The run space is that environment that it runs the PowerShell commands in and has its scope tied to it. So IronPython can create a PowerShell run space, execute commands within that run space, and then handle the output. This is facilitated through that .NET assembly, which is that system.management.automation DLL. And then this is just an example of that, of getting the information where you're running. You create a run space, you open the run space, you create a pipeline, which is just how you pass information into the run space. When you add the script to the pipeline, it kind of skips that step where we're creating a script block, where in the IronPython where we're creating that script. This add script's kind of that similar process. It's doing it slightly differently, but similar thing. Then we run it, we get the results, and we close it. So now we'll go through exercise 5. And after this exercise is where we actually get into the AMSI bypasses and stuff.
And this one you can run from that IronPython console. So we're going back to that console that we used at the beginning.
Yeah. Yeah, so we were talking about like you can run it directly in the console. If you try to paste the whole thing, it's going to say like, hey, this could screw stuff up if you don't have things properly formatted. But we went ahead and ran it. I will print this into Visual Studio so we can look at it a little more in a second. So we did print the output after we ran our invoke, and we have this really long thing about object module collections and like the system.management.automation.ps object. That's because when we do print output from the PS invoke, it doesn't output like a list or a dictionary that IronPython knows how to interpret. It outputs a PowerShell object, even though it is a list of items that it is maintaining or a dictionary. Because it's a PowerShell dictionary or PowerShell list, IronPython doesn't know how to handle it because they are different objects with different handling types. So we have to actually iterate over this and pull it out properly, which we'll do in the next script. So I'm just going to show you, make this a little easier to read, so we can go through real quick. So we're importing the CLR like we did last time. We're adding a reference to system.management.automation so that it knows where it is, and then we're importing PowerShell. We're creating a PowerShell run space, and then we're adding a script into it, and then we're executing it. It's pretty straightforward. It's not super complicated. So if we want to be able to read our output, we have to add another 2 lines. Which is just a 4-line in output. So it knows how to interpret that line. Basically, it's iterating through their list and printing it out. So you can still see that it is a system.diagnostic.process object, which is a .NET object. But we can at least see the names now. The reason these are still objects is if you do like a PS here, it prints out this table. Oh, no. It prints out this table with like the handle and all these other things and the ID and the process name. That's what this system.diagnostic.process object is. So it has all of those. Oh, why is my brain blanking on what that's called? Anthony, help me out. Attributes. It has all those attributes that you can access and pull that information out of and read it. But we didn't go through every piece of the attribute of each one. We just iterated through what each of those objects are, and we just get the name of the object along with it's a system.diagnostics process object. So now on to the fun part, AMSI bypasses.
Yeah, this is your favorite part.
Yeah.
Do we need to pause for a second? Does anybody have any questions?
Yeah.
This is probably like IronPython.net by Firehose right now.
Yeah.
Either everybody's an expert or you scared everybody, Jake.
Well, how many students do we have? Did everyone leave? How many participants do we got?
There's still 72 people.
Oh, okay, cool.
So you didn't scare that many people
I
yet.
didn't scare everyone away yet. Cool. So AMSI, you've probably heard of the term AMSI before. Whenever you first start trying to run like offensive PowerShell scripts, or anything like that, and it blocks you, that's what is happening. So like if we go over to this, we type in a known trigger word like AMSI context. Oh, apparently I have to. Oh, I'm in the IronPython console. That's why. It has to think about it because it's malicious. So whenever you see like an error like this, that means that AMSI has blocked it. That is a thing that was added into PowerShell after PowerShell started becoming very popular for threat actors to leverage for malware. And the big thing is that it's a antivirus agnostic interface. So when you run PowerShell, like load that system.management.automation DLL, there are hooks that pass it to AMSI automatically when you compile the PowerShell. The big thing that it does is that it evaluates commands at runtime. So this means prior to AMSI being integrated in PowerShell and in a lot of scripting languages, because AMSI is integrated across a bunch of stuff in Microsoft now. A really common way, and it's still common, especially on some of the unmanaged code for like C coding and stuff. Like you may have heard the term crypter from someone if you've done anything, looked at any of the on like the dark web or read anything about people like selling services for malware to like make it the fully undetectable, which is a bad term because there's nothing's fully
I
undetectable.
hate
It's
hate
just
the term. Oh, it's the worst.
but if you've heard anything, you'll hear like cryptors. People would encrypt their code, whether it's XOR encoding or like AES encryption or something like that. The AV would try to signature it because you can basically create infinite signatures with encryption. Depending on like the IV you use for it, like it was very difficult for AVs to create any reliable signatures on it. After it was scanned, you would decrypt it and run the code. To combat that, when you're using a scripting language, AMSI was introduced because the code has to, it is reading and evaluating the code when it is going into the compiler, which means that it has to be readable by the compiler. So it has to be unencrypted at that point. There are still ways which, if you want to learn more, we have a couple of like a couple of YouTube videos that we've published on obfuscation, specifically like on how do you still obfuscate stuff going into AMSI when it has to be unencrypted and all that. Like we have some YouTube videos up that you can go look at about that. I can go on and on about it. But it removes the largest leverage that malware developers had in their ability to hide their code in that encryption sense because it was so easy to create encryption that just like couldn't be signatured properly. But it provides an interface that any AV can use. Like if you're running McAfee or Avast or whatever, they all still use AMSI now. They just have their own detection libraries on the back end for comparing the signatures. And it specifically targets fileless threats. But AMSI is really good at detecting PowerShell using string matching. That's how AMSI works. Is it's still just even like we mentioned that like CLR load, like the assembly.load is like when the CLR is passing it to AMSI. It's still just serializing, which means converting your assembly into a string and sending it over to AMSI. So everything's just string matching, or byte matching is really probably what they're doing for patterns. It's really good at AMSI's really good at detecting malicious PowerShell. It's mediocre at detecting C#, and it is terrible at detecting anything else. I think our friend Kevin, who sometimes joins us on these, finally saw like a JavaScript detection after like several years, like a couple months ago, like the first time he'd ever gotten blocked by AMSI for JavaScript. But it was one of the core security features that was added into PowerShell to cause people to migrate away from PowerShell along with script block logging and some other stuff that's not relevant for this. But everything gets passed to AMSI at some point through the CLR is basically the main takeaway. Um, so um, the reason we want to disable it is because we can. Microsoft does not consider it crossing a security boundary to disable AMSI because AMSI is loaded into the user context of a process, which means if it's our own process, we can disable AMSI. There are some things being done to disable, make it harder to do the bypass that we're going to show here, which is patching memory. So like certain EDRs start doing stuff where they'll periodically scan the AMSI DLL. If they see that the DLL has been patched in memory, it reverts it back to the original functionality. That undoes it. But there's lots of AMSI bypass methodologies out there if you want to go research it.
And it's interesting, Jake. I was just reading through the core CLR stuff. They even say that they purposely don't reinitialize it because it's considered expensive when it comes to coding. So I
Yeah,
thought that was fascinating that like Defender and everything else purposely doesn't reinitialize it because of the expense associated with that. But now, I mean, you talked about Chrome tabs and everything else when it comes to memory, like just throw more memory at it and you fix the problem essentially.
yeah. Um, so the CLR has that single AMSI hook in it. Um, and in IronPython, we can leverage the C types library. So all the, like I said, all the APTs and stuff are using PowerShell still for a lot of these things. What they're doing is what we're about to show you, but they're usually doing it from C# or from C, which is leveraging the Win32 APIs to patch the AMSI DLL. Like Anthony said, they don't fix the DLL because reinitializing the DLL into memory every time you open a new compiler is expensive. Um, but we're going to use the C types library. It's a foreign function library for Python that allows you to call C functions directly. Um, it's really cool. Once we run this AMSI bypass, we can then run whatever we want in PowerShell, and Defender will no longer complain about it because the scanning function has been blinded.
So before you do that, Jake, somebody had a question. If we so it was added in 4.8, does that mean that 4.7.2 is preferable when creating a project and we can do strict shady things with it? Um, I can take the first part of that. So it actually matters on what version your target has installed. So if they have 4.8 or higher installed, then they have that functionality. And Jake, correct me if I'm wrong, even if they compile against an older version, that backwards compatibility in like the 4.8 version the target has will have the detections in place, correct?
Correct. Yeah.
Okay.
I was also going to say if you can find something with 4.8 installed or 4.7.2 installed, then like sure, but we're on version like 7.5, and I think the last system that was built was like a Windows 7 like build 10 or something that so like you're very improbable that you're going to find a modern environment that like if you find a computer that has that framework version installed on it as its primary
They're probably also running
framework
PowerShell too.
yeah, it's not gonna it's probably not gonna matter what you do because that thing's so old that you can do whatever you want. um but so this is how you do DLL patching. Let me see if I have a really easy version or if I have it really quickly. I can grab it real quick. I'm gonna grab I just want to show you that basically this looks identical to the PowerShell AMSI bypasses if you've ever seen them. I'm
Are
just
you
grabbing the code real
yes,
quick.
I was say yeah,
Yeah.
give either show them a link or just pull it up. It is fascinating to see them side by side. There are some weird things you still have to do though.
Yeah. So this is the PowerShell version of doing that. I don't have a good way of showing them side by side
Can
with
you put I
in a
was say can you
readable size.
yeah, oh yeah, to make them readable, I guess. Yeah, that's the hard
Yeah.
part.
But if you look at them, they're essentially the same thing. So when you do it in PowerShell, you actually still have to define oh, maybe this will work. Nope, that was the wrong window. So you see like this kernel 32 where it's like get proc address. That is using the same thing here. It's just in IronPython, since you have C types, it's already done all the work um, to define that API for you. So even in PowerShell, we are still using the C# interface. That's what this string is. And when you're using add type, you're basically compiling C# in PowerShell on the fly, just to show again that all of these languages are connected into each other, and basically all comes back to C# at this point in modern Windows. So in PowerShell, this is called Pinvoking, which stands for Platform Invoke. It's how you access Win32 APIs. The IronPython does the same thing through C types. C types is just a predefined pinvoke for you. If we have time at the end, which I think we will, I will show you. You can actually also do native pinvoke in IronPython without using the C types if you wanted to, because C types requires you to bring the whole standard library with you. We don't really talk about too much in here, but when you run IronPython remotely, the IronPython DLLs only define very basic functionality in IronPython. You still use the standard the regular Python standard library that you have to bring along with you in a zip, which makes like your memory a lot larger. Although Anthony argues that it's not a lot larger because it's like 10 megabytes versus like 20 megabytes or something like that.
It's still less than a crim tab.
Fair. Or a sliver implant. Um, but anyway, without going too far down the window, it's literally doing the exact same thing in PowerShell as you are in IronPython. You're using the same functions, the same function names. The syntax is just slightly different because you're using different libraries from the language that the language that you're in. But they're like literally the exact same thing. But this is also where we are talking about that memory problem for Python, where like Python doesn't allow you to force data types because it's a dynamically typed language. You're not supposed to like statically type your data or your variables. So this is where we're using that system import to define like uint32s and int pointers that are like more standard C variable types, because when we pass them into these Win32 APIs, it has to take those data types. If they're not in that format, it'll throw errors. There are certain times that you can just pass it in directly, because it like when it goes through that C types conversion, C types properly cast it for you. But you're kind of playing like Russian roulette on like it'll work like 9 times out of 10, and then it'll be some weird thing that IronPython did, and it doesn't pass it in properly, and then it fails. So it's best practice to just go ahead and cast everything before you pass it to the Win32 API.
So this exercise has probably way too much information in it. But that's okay because we gave you tons and tons of information to go back and read through and work through. But like the highlights of what we'll end up doing is we're going to run a couple commands that are going to get flagged on your box as malicious. Then we're going to build a script to run that. And then which is essentially the script that we ran earlier. Um, and then we're going to run it with the bypass in place.
Yeah. So we're gonna grab that script that's there. Why is it not liking my?
So you don't. It's IronPython.
No, it's not IronPython. It's the Oh, this is IronPython. What am I doing?
I I
Sorry.
don't know.
Yes, yeah, sorry.
Notepad plus plus.
Yeah, I don't have it installed on this box. Yeah, thank you. That's why it's not working. I already have it built on this box. Got too many windows open. So, um, I should have installed Notepads++. But so we're importing a bunch of different things for us to use. This is where we're defining that bypass. We're getting the handle to the AMSI DLL. We're passing in argument types that, again, like this is a lot of information. If you want to know how these things work, there's a lot of just search like the Rasta mouse bypass or Lieberman bypass. They're kind of both the same thing, slightly different. But you can find lots of write-ups that explain what each of these steps is doing in this bypass so that you can understand the patching part. We just don't have time to walk through it all. But basically, you're getting the address. You're overriding the end of a function with these bytes that tell it for AMSI to always return that nothing was detected when it scans it. And then you're patching the function so that the return is always the same instead of so AMSI actually scans it, evaluates it, and then the evaluation just gets dropped because we hard coded the return value instead of passing in what was actually evaluated.
Essentially comes down to is they said as a design decision, if AMSI fails to initialize, the program still needs to run. So it still runs with AMSI not working.
Yeah.
So fail open versus fail secure.
Yeah. And then this is just the code where all we're running is that AMSI context string that I showed earlier, because it's a known trigger word. This is actually one of the things you can patch to bypass AMSI. So like again, getting into our inception stuff, PowerShell / AMSI has a bunch of stuff that it scans before it gets executed to see if it's trying to mess with AMSI itself, so it's protecting itself. Because known AMSI bypasses are tried to be detected by Microsoft. They just don't view a AMSI bypass as like a security boundary breach, even though they do try to protect against it. And then this is just adding a main function to our script so the script knows to run this when you start the script up itself. So we're going to go ahead and comment out this bypass line and save it, and we'll run it.
It's going to be angry.
Mm-hmm. Yeah. So you'll notice we don't get this red text because this was executed from our IronPython code. So like it went, and so we executed from we told the IronPython console to execute code from PowerShell, and then it gets passed back in it, and it doesn't have the error handling that does the coloring for PowerShell in our IronPython code. So it just passes it back as like plain text instead of having the coloring added to it.
Sometimes you won't even get that back. Sometimes it'll just kill the entire process. And you'll get a bunch of Python errors, and that's also not fun.
Yeah. But now if we put our bypass back in place and execute it. But this is one way to know when you get it like white like this instead of red, it is one way to know that it failed within our Python script and not that our Python script itself was blocked from executing. So but then you can see that it did execute this time because we were able to patch AMSI prior to executing stuff, and depending on how it launched, I can't remember last time if I tested this. We might have actually patched AMSI in this process. Nope, never mind.
Yeah,
I guess because a separate process.
Yeah, I was gonna say it's either a separate process or a child process.
Yeah. But so that's bypassing AMSI.
I linked the paper if you're interested. There's a lot of material on AMSI patching and all that stuff. If you're interested to dive into it, definitely take a look into that. It is super fascinating. And it requires a lot of obfuscation nowadays because a lot of the bypasses are well known, like Jake said. So they catch the bypass, so now you're in trouble. So you have to obfuscate them. But this one doesn't get caught currently, which is nice. Um, and that goes back to just the way we're constructing it because they can't reach into the CLR the way we're running things. So
or into the DLR.
DLR, thank you.
To the DLR.
The CLR is what's scanning.
Yeah. So the last thing we have is just showing how you can embed EXEs into your IronPython code. So if you have ever seen what does Secure This Shit call the projects? It's a
Uh,
Power Pack.
yeah, PowerShell pack, I think.
PowerShell Pack, yeah. You ever seen PowerShell Pack from Secure This Shit, where it's basically just a bunch of like Rubius and all of those popular like Ghost Pack tools and other popular like C# tools with like PowerShell wrappers on them. This is essentially the same thing, just with an IronPython wrapper on it. So all of this is like all this like random shit that you're seeing right here is Rubius.exe converted into a base64 string. We're running like our AMSI
Oh,
bypass.
not just the base64 string. We did have to compress it using a
Oh yeah,
library
yeah.
because AMSI is smart enough to scan and look for base64 encoded just packages in general. So it knows what Rubius and like other things look like if you just base64 encode them. Just because it's a common way of just sending data, so it knows to look for that. But if you apply some sort of like compression on that as well as base64, it doesn't know what to do, and you get it right by. So,
Yeah.
um, so that's once we go to run it though, we still have to include our bypasses, what Jake's about to go talk about.
Yeah,
So
so we're running our AMSI bypass here. This is our base. This is to undo the base 64 encoding, including decompressing it. So yeah, base 64 bytes. So it decompresses the data, and then returns the system array. And then this is again that typecasting that we talked about. This is where you get some weirdness with it. So you have to go through the entire list and cast each item individually into a type to make sure that it is properly formatted so that the CLR knows how to handle it properly. Then we're going to load the assembly using assembly.load because we have access to that directly. And then we have to convert the command that we send to Rubius into a proper array from the string, and then we can invoke Rubius at the end. So when we go do this,
it's super simple, and I'm sure everybody got it.
so this is also where we are talking about. So we're going to run Iron Rubius. It takes arguments, so we're just going to put the argument after the file name, and then we're going to run it. And then so now we've executed a .NET exe from IronPython without like, and if we were running everything from like an agent or whatever, this would have ran entirely without hitting disk. So we can embed exes or .NET assemblies into our IronPython code, execute it by undoing it, execute the assembly, and then pass the information back through IronPython.
And if you go to download Rubius or compile it yourself right now, you'll notice when you try to run it, it gets flagged as malware and it won't run. So
Yeah.
this is a way of us running that C# code in kind of a roundabout way to get past all of those things.
Yeah. So that's kind of everything we had. We had like 5 minutes left for any questions. I can also show you guys one other kind of cool thing that I've built. So we've been talking about that platform invoke stuff. So this is a shellcode injector for IronPython. This was rebuilding some of that IronNet injector that Torla built because there were no known functional samples of how IronPython was doing the .NET injection. So this is built entirely without using the IronPython standard library. So all this is using is an IronPython DLL to run all of our .NET commands through the DLR where there's no instrumentation, so that you can bypass stuff. So this is doing our platform invoke. So that C-type stuff we did, this is just doing it manually. And executing it, this is just popping calculator, which I'll show you guys in a second, and just does a shellcode injection from our IronPython process into any arbitrary remote process that you have access to. So let me open. Oh, we got Notepad open. Notepad's probably gonna crash because we'll do PS. We'll go grab the process ID for Notepad. So 3104. And then that popped calculator. It does. There's something weird going on with Notepad. It shouldn't be crashing when it does, but it started crashing this morning when I was testing it. But calculator still gets popped, so our shell code got executed. Yeah, and then it starts back up. So our shellcode executed through that. Like I said, the cool part is because we executed through the DOR, there are no security hooks that could see what our code was doing. So we're a lot less likely to get blocked. Because like if you wrote just a traditional C# shell injector, it'll get blocked. The assembly will get blocked because they know that that's like a bad thing that you shouldn't be doing. So by running through the DLR, the assembly doesn't get blocked because it's not an assembly. It's a abstract syntax tree that doesn't get scanned.
Yeah, Jake was working on this today. Super cool.
Yeah.
So this starts getting us into that weird back into unmanaged space now. That was the stuff that we mentioned earlier with Turla, how they use C# into IronPython and then into like unmanaged space. This is where you can load like BOFs and other things to get you into that unmanaged space.
Yeah.
Does anybody have any questions on this? Otherwise, I got a couple questions I wanted to bring up for Jake to answer. And feel free if anybody else has questions, start typing them out. It's kind of what we'll do for the last couple of minutes is answer any questions you guys have left. First, since AMSI does like strings matching and a string matching based, are there any bypasses that leverage UTF-16 or Big Indian, or left to right parsing or similar text encoding variants? I think I
Uh,
know exactly what you're going to say. Go ahead.
no, that's the whole that type of thing is what AMSI is specifically designed to beat. Because the UTF-16 encoding isn't readable by the compiler. So you can do things like like write all of your like have your code where it's like written all out in a byte string using like or hex or something like that, and then your code converts it itself. But if it's executable code, so like you can hide functions that way, or not functions, like variables in certain pieces that way. Like that AMSI context is like a string that gets flagged, that you need to like find like the get proc address within the AMSI DLL to figure out which function you're patching. So like you could hide that name, but like if it's actual executable code, the compiler has to be able to read it. So there's not really any ways to do that. There are certain ways to do some bypassing and stuff in the sense that also variables are never scanned until or like the internals of variables are not scanned. It's just the variable creation is the code that's scanned. So you can pass some things in, but if it ever gets converted into a script block, it will go through the AMSI scanner at some point.
Yeah, that gets into so Jake is teaching a evasion workshop at Black Hat. It is like by far his like favorite thing to talk about. He spends 2 days just talking about the intricacies of like evading EDR, and it makes my head want to explode because he's a genius when it comes to these things, and is not where my specialty's at.
Yeah. And then we have some additional research that hopefully is going to be coming out at conferences this summer. So we got a question that says if the AMSI scanner is disabled or bypass, does that disable all other AV systems? So it depends on how the AV system is functioning. So if it's traditional antivirus, like just like your McAfee home scanner or whatever, essentially yes, because AMSI is what's responsible for passing it to the AV for evaluation. So if you've blocked it, then the evaluation never occurs by the AV. If it's a EDR like Carbon Black or whatever, it doesn't disable things like your ETW events that it can look for, or other behavioral things like opening handles to another process. But it would prevent any like PowerShell detection by those, like it detecting specifically that malicious PowerShell happening. It would just be detecting on behavioral things at that point.
Yeah, because AMSI is just a AV agnostic interface to whatever your antivirus is that you have. It allows you to install whatever you want. So take Defender, swap it out with whatever AVG, Vast, McAfee, you name it.
Yeah. Oh, and then the last thing that we were going to announce is we just released an on-demand course for Empire, our command and control framework. And we'll be sending out a code for everyone that's going to have a 10% discount for the code if anyone, or for the class if anyone's interested in taking that. Or if you have any questions about it, feel free to ask. Empire is a really cool C2 if you haven't used it. It's not necessarily the most advanced, but our whole shtick is building it around emulating like threat stuff that's going on in the real world so that it actually matches like Russian and Chinese APTs and that kind of stuff. So a lot of the C2s out there are built to be like the Gucciest, doest TTPs that aren't really matching what actual real world threats are doing. So our whole stuff, our whole shtick at BC Security is threat emulation. So it's built to match that. And lots of I mean, it does have all the hooks and stuff in there to be able to build out like cutting edge TTPs if that's what you want. We are adding a whole bunch of this IronPython stuff into it, so it will be have all of that kind of newer techniques in it, just because we actually have some threat intel that shows that the stuff's being used now. But super cool class, and if you have any questions, feel free to ask about it.
Yep. And then I posted the link to it with the code. We'll also email that out in case anybody missed it. And then if you haven't already, feel free to drop into our Discord channel. We're happy to answer any questions. If you're walking back through these things and you just run into something, we're both happy to answer any questions. I mean, if you're going to ask me about IronPython, I'm excited because this is the stuff that makes me excited. So, all right. If there's not any other questions, thanks everybody for showing up. We are only 3 minutes over, Jake. Great job.
Yeah, we did a good job.
All right, thanks guys. I'm going to end the recording unless anybody has any other questions.